Okay, so now coming back to this problem, the next thing that I would do is, like I said, I'm going to replace these four variables in terms of other variables. So I know FC is the adjacent side of this triangle. So I know I could write friction, I could write FC as F times the cosine of the angle, right? Because that's the adjacent side. So I could write FC as F times the cosine of the angle, but I'm going to take it one step further. I want to actually have everything here in terms of Fn. Well, friction equals mu Fn. So I'm going to actually replace FC with mu Fn cosine of theta. So I'm replacing FC with this. That's friction. Mu Fn is friction, and the cosine of the angle because I'm taking the component of friction, not the whole friction. So this has now been replaced with that. Now I'm going to replace FNC. Well, FNC is the opposite side on this triangle. So I'm going to write it as the hypotenuse times the sine of the angle. All right, that would get me FNC. So this is going to be plus Fn times the sine of the angle, and that's going to equal mv squared over r. So that's my first equation. Now, with the other equation, I'm going to replace Fny. So if I look here, Fny is the adjacent side of this triangle. So I'm going to replace it with the hypotenuse, Fn, times the cosine of the angle. So I'm going to write Fn times the cosine of the angle. So I've replaced Fny with Fn times the cosine of the angle. Now it says minus Fy. So Fy is right there. That's opposite this angle. So I could replace it with F times the sine of the angle, but again, I'm going to replace friction with mu Fn. So my equation is going to be minus mu Fn sine of theta, and that's going to equal, I'm going to take the W, because I want them to sort of look the same. So I am going to take the minus W and move it to the other side. But I don't want to write it as W, I'm going to write it as mg. Because I don't want m and w with my equations. I'm trying to reduce the number of variables I have. So when I move it to the other side, it's going to equal mg. Does everybody follow that? So now, what I can do is I still have things I don't know. I don't know what the normal force is. Maybe I know the angle, maybe I know V, maybe I know R. Again, I didn't identify what my unknown is. I'm doing a very general problem where at this point, any one of those things could be the unknown. Yes? Just so that it looks like this, where I have two terms, my Fn terms are on one side, and I put everything else on the other side. And now what I'm going to do is, since both of the equations have m, I'm going to take the second equation, and I'm going to solve it for m so that I have something to substitute into the first equation. So I'm going to take the second equation and solve it for m, which means it's going to be Fn cosine theta minus mu Fn sine theta. The algebra is pretty simple here because all I have to do is divide by g, and that gets m by itself. So I just took the second equation and solved it for m, and now what I'm going to do is I'm going to take this and I'm going to substitute it right there. And then there won't be an m in the equation anymore. And what you might notice we're going to have is also, if I replace this for m, then every single term will have Fn in it. So that's going to eliminate Fn. So I'm going to kill two birds with one stone here. I'm going to get rid of m, and I'm going to get rid of Fn just by doing that substitution. So I'm going to get mu Fn cosine theta plus Fn sine theta equals, and what I'm going to do, if you look at this, I am going to, when I plug this in here, I can see that I've got a G and a V squared and an R. I'm going to pull all those out and just have this in parentheses. All right, rather than just distribute it in. I mean, I've already got a fraction here, and I'm plugging it in there. So the G would be, this G would be down there with the R, and so what's left will be the numerator. So I'm going to have V squared over RG, and then in parentheses, I will have the top. I'll have that. So I'm going to have, in fact, since it's in blue, just to show you where it's coming from, maybe, in fact, let me do one other thing. I want the G, because the G was part of that, so there's the G. And then in parentheses, I'm going to have Fn cosine theta minus mu Fn sine theta. So look at what I have on the board at this point. Do you see what I did? All I did was substitute for m, and now every term has Fn in it. Fn there, and if I distribute this in, that term's going to have Fn, and that's going to have Fn. So what I can do is cancel them all out. So if I divide both sides by Fn, all the Fn's are gone. And now the equation is exclusive to the variables that I have over here. Whoops, I need to move this over. To these variables that are up here. M, V, R, theta, mu. In fact, M, I didn't even need M. M's gone. So V is over there, R is over there, theta is over there, and mu is over there. So I've got everything that I need. At this particular point, now it would depend on what the unknown is to which one you're going to, how you're going to move things around. I suppose I would do one more step before I would have to worry about which one the unknown is, and that would be if the equation contains fractions, multiply by the least common denominator. So I'm going to do that. So I would multiply everything by RG. That would be my next step. No matter which one of those variables is the unknown, I would do that next. So what I'm going to get is I'm going to get mu RG cosine theta plus RG sine theta now when I multiply the right side by RG, the RG cancels out the RG, so I'm only left with V squared. So I'm going to distribute the V squared to both of these, or if V was the unknown, I wouldn't do that. I would leave V squared there and leave this in parentheses, because if V was the unknown, I would eventually want to get, I'd want to factor out the V squared. But if anything else is the unknown, if theta is the unknown or if mu is the unknown, then I would actually distribute this in. But for now, I'm going to distribute it in. Let's say the V isn't the unknown. Then I would have V squared cosine theta minus mu V squared sine theta. Everyone with me to here? So now, let's just look at the possibilities. If mu is the unknown, then I would take this term and I'd put them on the same side, and I'd move this one over there, and then once I have mu on one side, I could factor it out and then get mu by itself. If r was the unknown, then it wouldn't look like this. It wouldn't look like this if r is the unknown, because I wouldn't have used mv squared over r. I would have used mr omega squared. Okay, so if r is the unknown, it wouldn't look like this. If theta is the unknown, now look at if theta was the unknown. If theta is the unknown, this is how you'd have to do it. I'd have to take my two sines, this term, and put them on the same side, and take my two cosine terms and put them on the other side. Then I could factor out on one side I could factor out sine theta, and on the other side I could factor out cosine theta, and then bring the cosine theta down so it's sine theta over cosine theta. And what does that equal? Tangent theta. And whatever's been moved to the other side in order for me to get sine over cosine, then I will have tangent theta equals that mess that would be on the other side, and then I could solve for the angle by taking the inverse tangent. So any one of these things could be the unknown. The way I have it here, v could be the unknown, mu could be the unknown, the angle could be the unknown. The only thing that this would not look like this would be if r was the unknown. Because I come back to here, that would have to be mr omega squared. I couldn't use mv squared over r if r was the unknown. All right? Any questions with that?